Kart is an open source software project for data version control for geospatial data. So the purpose of Kart is to make it easy to store your spatial data in a way that you can make changes to it and see those changes and push and pull those changes to other people, so collaborate on that data as well. So we sort of see, the way that people work in the GIS world. We work with a lot of files on your disk or on sort of a network share, and we have this sort of problem with how you manage all the copies of your data. Kart is our attempt to sort of solve that problem.
Hi, and welcome to another episode of the Geospatial Africa podcast. I'm your host, Inewong Benson, and in today's episode, I'll be talking to Hamish Campbell. So he's the product manager for Coordinates.com. That's a company in New Zealand where he steers development in their special SaaS platform for large-scale spatial data. He's also the OSGeo Oceania Chartered member and the Force Fuji event organizer. Thank you so much for being here, Hamish. It's a pleasure to have you on the show.
Thank you very much, Anibong, and it's exciting to talk to you.
Yeah. So today we're going to talk about Kart, right? The Kart project. I mean, a lot of people haven't heard about it. When I came across it, I was really impressed with what it can do. So that's why I thought this would be a great opportunity to have other people hear about Kart and maybe start using it. So before we dive into the discussion of the day, could you tell us about yourself? How you got into Geospatial?
Yeah, it's a funny story, really. A long time ago, I used to work for a fast food delivery company, actually, here in New Zealand, and I was taking phone orders, and we had this big database of complaints for overdue orders. And Google Maps first came out in New Zealand, and this probably makes me feel very old right now, around about 2008, I think. And I remember using that service to geocode these overdue complaints to figure out where deliveries were being late, and I put that on a map. And I didn't realize at the time, but I was doing some GIS analysis, and I think that's kind of where I got the bug. And from there, I was doing some software development and moved into a GIS team at an engineering company. And there we were doing, lots of civil engineering projects and, water and roads and that sort of thing. But I was a GIS developer helping them. And we were using all this data from a company called Coordinates.com. And Coordinates made it really easy to get data, and we were using it all the time. And Coordinates was a tiny startup back then. This was a long time ago. But it was a decade ahead of where other GIS portals were and how easy it was to find and get data. And in that team, we would use it pretty much daily to get the data that we needed. So I started talking to the CEO, Ed, and eventually joined the team. And that was 2011, and we've grown from 4 to 25 people. And we've still got a lot of exciting stuff on the horizon too. So that's sort of how I got into Geospatial as a software developer. Since then, I've also got involved with OSGeo too. So I'm part of OSGeo Oceania and a Phosphagy organizer. So yeah, so that's me.
Awesome. Thank you so much. That's really, really interesting. I mean, think about where you came from, taking orders and all of that, and then actually using, Geospatial technology to improve this. And then now you're moving into being a full, GIS developer and, solving problems. I think that's really, really interesting journey there.
Yeah, you said in one of your other podcasts that it was one of the easiest industries to sort of fall into, and I feel like that's me.
Yeah, awesome. So I know that you are a product manager at Coordinates, right? So what's your daily work like? What do you do at Coordinates as product manager? Could you tell us a little bit about that, though?
Yeah, broadly speaking, it sort of means gathering the upcoming work, figuring out what to do, breaking it down. So, we're a small software company, so breaking it down, making sure it gets done. I kind of think of it a bit like air traffic control. So, we've got some really highly capable people, and they know what they're doing, and they're working on lots of different projects. And my job is really to give people what they need to take off or, get their work started and provide some redirections along the way. And then sort of make sure everything lands properly at the end and things don't intersect or, cause problems. So, we're a SaaS product, so a software as a service website at Coordinates.com, and it means it's, we're operational 24/7, and you're trying to fix things and add features and monitor how things are going all the time, a bit like maybe an airport that never shuts. It just has sort of quiet and busy times. So that's kind of how it feels like, right? You're sort of coordinating a lot of work. And trying to get all the work done. It's exciting though, and no two days are ever the same.
Yeah, I wouldn't doubt that for a second. I think it's really great. I think you're working with really amazing people there. So let's dive into talking about Kart, the Kart project now. I did a poll the last time on Twitter, right, to try to understand how many people know about Kart, who's using Kart, and who has heard about Kart before. So it seems like a lot of people haven't heard about Kart. So that maybe this is the time for you to share this information with us. So what is Kart? What is the Kart project? Could you tell us about this?
Yeah, so Kart is an open source software project. So that means that it's freely usable. Everyone can look at the source code and make modifications and use it. So without any no payment at all. It's an open source software project for data version control for geospatial data. So the purpose of Kart is to make it easy to store your spatial data in a way that you can make changes to it and see those changes and push and pull those changes to other people. So collaborate on that data as well. So we sort of see, in the way that people work in the GIS world, we work with a lot of files on your disk or on sort of a network share. And we have this sort of problem with how you manage all the copies of your data. And Kart is our attempt to sort of solve that problem.
Right. Cool. So we're going to come back to the data management part of Kart. But could you tell us a little bit about the history of Kart? Why was there need to build this software? Because I know it was formerly called Snow. So why the name change? And tell us a little bit about the history behind Kart.
Yeah, there's an old joke in software development. There are only two hard things in computer science: cation validation and naming things. And it's sort of the naming things is what we're talking about. We have a convention in our internally of using names of flowers for working names for projects. So when we start up a new thing and we need a name, we just pick a flower. And Kart actually started off as Snowdrop. But software developers are also lazy and don't like typing, and we shortened that just to Snow, S-N-O, three letters. And we really liked that name, and we all got used to it, and our muscle memory kicked in, and you type it really quickly. But unfortunately, we found that users were confusing that with Snowflake DB, which is a new-ish but very popular database solution out there at the moment. So we had to go and find a new name, which is a difficult problem. So we had lots of discussions and arguments, and we settled on Kart with a K, so that's K-A-R-T. And that's been good. It has interesting associations with mapping, the root word and cartography. But I guess most importantly, it was quick to type. So it's stuck now, and now we're used to it, and it's a good name, I think.
Thank you so much for sharing, a little bit about the history of Kart with the listeners. So, you did mention something about Kart being a distributed version control for geospatial and tabular data, right? So, I know that version control is a term in software development. So, what really is it, and why is it? How does it relate to geospatial data?
Yeah, so version control means the ability to keep different copies of your data or your code or whatever you're working with all together in one place, and to be able to easily get to different pieces and manage the change with that over time. Now, the reason that we got into it is because at Coordinates, we primarily help our customers publish lots of data, and then we help our end users consume lots of data. So we help, like government agencies, for example, who have heaps of data, and they need to get it out to planners and scientists and engineers who need to consume it for their work. And we're really good at that, but it's a one-way data flow, and changes hardly ever go back the other way. So you'd hear from customers all the time, how do I get feedback and updates on my data? And internally within organizations, they have exactly the same problem, right? So if you're working on changes to your data that you want to publish, managing the changes that you're making to that and preparing releases is still quite a difficult problem. And the end users too, so back when I was working in civil engineering, every project, you'd have your data folder, and you'd make copies of the data that you need, and then you would make changes to that data. But those changes would almost never move outside of that project. And if you ever had to update your data from, if there were changes that happen in the meantime. That was really difficult. And there are some tools out there. They tend to be very expensive, and they don't work particularly well for particularly projects that span lots of people and different organizations. But I work in the software world, and we have exactly the same problem with code. No one software project is written by yourself. You're always using code from other people. The open source world of code is enormous. And this whole problem of how you work with code between people has been solved for ages. So we've had systems like CVS and Subversion and tools like Perforce and now Git, which a lot of people will have heard of, even outside of the software world, is this really established and well-known, understood way of being able to collaborate on changes to some stuff. And in the code world, you're really talking about text with a whole bunch of people, and doing it in a way that's really reliable and safe, so it's difficult to accidentally lose things. Which if you've ever worked in the GIS world, you know how easy it is to lose a bunch of changes when your software crashes. And so the question is, why not for data? That's what Kart is about. It's about how you do collaboration and manage changes to data, not just for yourself, but within your team and then within the organizations that you maybe work with. And that might be data suppliers or consumers of your data inside and outside of your organization as well. So that's what we mean by version control.
So thank you so much for breaking that down for us. So I did hear you say that Kart solves the problem of managing changes on data sets, right? Because in GIS we're always making changes, right? We're always adding, deleting, updating stuff, and I think there's always a need to be able to track these changes, right? And I think in the commercial world, if I'm not mistaken, I think there's a software that allows for where you have different versions. I think ACT does that. Is that comparable in any way to what is achievable on ACT, for example?
Yeah, there are tools out there, but they sort of suffer from a few problems. For example, that's great if you have a tool that you use internally, and that's your tool. But if you actually want to then push and pull changes that you've made to other people outside of your organization, and they don't use that same software, then you're in a bit of a bind. A lot of the existing tools as well, they're focused on like a linear or sort of one-way change. So you can make a change and then you can make another change, and you can only sort of lock the whole thing and make a change and then unlock it. And if someone else is already making changes, then you can't jump in and do things. So that's not in Git and a distributed version control system. You can have multiple people making multiple changes all at the same time, and the version control system is able to pull those things together. So I highlight that Kart is actually built on Git and teaches it how to work with spatial and tabular data. And unlike some of those other tools, that means that you can have lots of people working on the same data at the same time in different places. And it's distributed version control. So I can have a copy of the repository. You can have a copy of the repository. We can put it in multiple places, and we can send those changes between each other without having to have any particular type of centralized location for storing it. So there have been other tools in the GIS world as well around. So we've learned a lot from the GeoGig project, for example, which was an earlier project that had a similar approach, but didn't build on Git itself. So we've tried to maintain compatibility with Git, so you get all the features that you get with Git, but wrapped up in with Kart to provide some spatial sort of capabilities as well.
Well, that's really awesome, because I've used Git before, so that feels like if I know how to use Git, right, it's easy to now use Kart, isn't it?
Yes, exactly. If you've used Git before, then Kart should be very natural to you, and you should all the things that you are familiar with Git work as similarly as possible. So we try and make it work the same way, but then it has extensions to Git that let you do spatial specific things. So, for example, you can do a spatial filter on your data. So if you have a data set that's for your whole country, but you're only working on your street, you can actually spatially filter your data so that you're only working with your local data and you've got a much smaller data set, but you can still do all the things you need to be able to do. So you can still save changes and share those changes around, but without having to deal with the entire data set.
Wow, I think this is really interesting, and also the ability to support multi-editing workflow. I think that's really brilliant. I think because it's going to be using teams, organization that have a lot of data, and then they also need to be able to track changes made by different people in the organization. I think I also love the fact that with Kart you have that liberty of working in a cross-functional team. You don't have to be using the same software, like if you're bound to some kind of proprietary software, right? People can basically use Kart irrespective of what software they're using.
Yes, exactly. So we're really trying to bridge the gap between different types of software, and not only within the GIS industry as well, right? So we're really used to people using the tools that we're familiar with, but we have a really broad user base, and it includes people who use design software or software developers who don't really know, are not super familiar with the underlying concepts that you need a proper GIS for, like about CRSs and projections and things. But they want to build other things on top of it, and software and websites and that sort of thing. And Kart is really a bridge between all of those different use cases.
Awesome. So let me take you back a little bit. You did mention a bunch of terms, right, when you were talking about Kart, right? Like repositories, working copies, branch, pull and push. Could you break this down a little bit for us in case there's someone listening that is not really familiar with these terms? So what is a repository? What's a working copy, a branch? What does it mean to pull and to push?
Yeah. So a Kart repository it's kind of like the raw data store for all the data in your project. So by default, that has a complete history of your data set. So it's not just your data that you have right now, but it's also all the changes you've ever made to it, and other little bits of metadata about what you have, right? So not only do you have what you have now, you have how it got to be like it is now. And one of the really nice features of Git that we sort of inherit in Kart is you get a cryptographic key that lets you verify the state of your repository. So what it means is, if I share that key, or it's called a hash, a bunch of letters and numbers, and if I share that with you, you're able to verify that the data that you have matches the data that I have, which is really great for shortcutting. Like, do we actually have the same data? It becomes very easy to check that. So that's a repository. It has all the data. The other important phrase is working copy. So the working copy is the piece you're looking at right now, and it's the one that you're actually editing and viewing in your JS system, or linked to your project, or whatever it is you're doing with your data. So it's the data at a particular point in time, and you can edit it, and Kart will be able to tell you what has changed in that working copy and help you save those changes. So the other term that is important to know is a commit. So when you save the changes or commit the changes, you're actually putting a new copy into the repository. It does a lot of clever stuff to save that as a change to your data, so you're not having to resave the entire data set. But you commit your change, and then that change is now part of the history of your data set.
So basically, I can actually have a history of all the changes that's been made, and you can look back and say, oh yeah, I think I can go back here, I can go back there, and see what changes were made at different point in time. Yeah.
And now we get into some more advanced things. So a branch is like a different version of the data in the same repository. So when you create a branch, you say, okay, I want to create a new history of the data, and you can commit your changes, so saving changes into that branch. But if you want to go back to the previous branch you're working with, you can check it out. So that's another term, but it means going back to a different version of the data with a different name, and being able to switch between different things you're doing. So you could have your main version, which is the current copy of the data that is current and most up to date. But you can have a branch for different editing tasks you're doing, and you can switch between them. And Kart will keep your working copy, so that's the one that you're sort of viewing at any particular time. It'll always keep that up to date. And then when you're happy with a bunch of changes you've made on a particular branch, you can do what's called a merge. So the merge tells Kart to figure out what has changed on a particular branch and then pull those changes back into what you're looking at the current time. So if you've finished a bunch of editing, you can run the merge, and then you've got a new history of your data that has all of your changes from that branch that you created before. So I guess the last piece of the puzzle is how you actually share those changes around, and that's where pushing and pulling comes into it. If we push a change, it means we're sending your changes up to some other location. So it might be a central server or another repository on your file system. And what that does is sort of find the differences between what you've got and what the other person has, and then pushes those into that other location. And if you're doing a pull, it's the other way around. So when you do a pull, it finds the changes that you don't currently have and pulls them into your system. So between all these different things, you can create new branches, make changes to those branches. You can push and pull those changes around, and you're able to work with other people in a way that lets you choose how you want to work. So you can have your own branches, and you can choose when and how you want to pull and push those changes between each other.
Awesome. I think that's really like a lot of things to unpack there, and I think it's really, really interesting what Kart can do. So we've talked about Kart, and I'm sure a lot of people are thinking, how do I get Kart? So could you tell us how can someone get their hands on Kart and start using it?
Yeah, certainly. So the easiest way is you head over to the project website. So that's kartproject.org, and that's Kart with a K again, so kartproject.org. And then you can download it for all the major platforms. So it's really important to us that Kart works on every platform. So we build for Windows, Mac, and Linux. It's also important to us that Kart is a bells and whistles included type project. So you should be able to install it, and everything should just work, and you should have all the pieces that you need to start using all the capabilities of Kart. That's been pretty challenging, but it's really high priority for us. You can also get it from GitHub. So if you want to actually start building with it, you can go to github.com/coordinates, that's with a K again, /Kart, and you can get it from there. And that link's on the Kart project website as well.
Oh, thank you so much for that. So I'm going to add the link to the show notes, so anyone who needs to get it could quickly go there. So say someone has got Kart now, and they're very eager to start using it. So could you walk us through a typical workflow of Kart, for example?
Yeah, so it's pretty easy to get started. And again, if you're familiar with Git, this will sound very familiar. So the most basic way to get started is by creating a new empty folder, and you run Kart init, and that turns that folder into a repository. So your repository is really just a folder full of stuff. And then you import some data to that repository, and there's a Kart import command. So that pulls in your data into your Kart repository and creates a working copy of your data. And from that point on, your data is part of the repository, and any changes that you make will be tracked by Kart. So if you make some changes to your data and save those changes, you can run like the Kart status command or Kart diff, which means tell me what has changed, and then you can commit those changes into the repository. So at that point, you're version controlling your data. From there, you can get into more advanced things like creating branches and merging those branches. And I think we've got a couple of tutorials at the Kart project site too that you can look at. Or if you want to start collaborating, you need to set up a server that can accept Git repositories, and then you'll be able to push and pull those changes between other people as well. So it's pretty straightforward to get started. Just Kart init and Kart import, and then you've got a Kart repository ready to go.
All right, thank you so much for that. So you talked about Kart being version control software for geospatial data, right? And we can talk about geospatial data without talking about different data formats. So what data formats are supported on Kart? If you could share that.
Yeah, so right now, Kart is mostly focused on vector data. So we support standard points, lines, and polygons, but also tabular data. So you can also throw in non-spatial database tables, that sort of thing as well. And those will be version controlled. For your working copy, so that's the the data on your disk that you're actually able to edit and work with. Kart supports GeoPackage. Kart started with support for GeoPackage. So that's a really great open source format. It's a pretty good drop-in for shapefiles if you're using shapefiles, because it lets you store multiple data sets in a single portable database. And it's well supported by most major software packages too. And so what that means is you can create your Kart repository and you get a GeoPackage that you can start using. We also support a few database connections. So you can create a working copy in a PostgreSQL database or Microsoft SQL database. You can also use MySQL too, although its spatial model is a little bit simpler and doesn't quite support everything in Kart. But what this means, though, is that you could do your data editing in QGIS, for example. But you could have another repository that is linked to your database that's in some other location, and making changes to your data becomes quite easy, because you can edit it in QGIS and you can commit those changes, and then you can push those changes to the repository that's linked to your database, for example, and you can pull those changes in very easily. So there's lots of ways of using it, and especially if you're working with vector data day to day, it will give you a lot of benefits straight off the bat.
Oh, thank you. So I hear you mention QGIS there. We're going to come to that, but I understand that Kart is a command line utility program, right? And so there's not that easy GUI interface where someone can interact with it, right? So is there any plan to actually develop a GUI type front end for Kart? I mean, this could help people who are not really technical, who haven't used Git before, or who are not really familiar with the command line. Yeah.
Yeah, I mean, we are super mindful that our industry, the GIS industry, is full of experts in their own domain. People who are they know how to work with databases and spatial analysis and all sorts of things. And we don't necessarily expect everyone to go and want to learn a new software tool with a command line. And we know that people will, but for a lot of people, we do want to provide a nice app to work with it too. So yeah, we are working on one as a company, and we want to build a desktop application for working with Kart repositories as well. And that's in progress, and hopefully we release soon. So that gives you a really good user interface for working with repository data and some of the visual aspects that you really need as well. So being able to visually preview changes is really important. And also merge conflicts. So if you've worked with Git, you're probably thinking, how do we deal with merge conflicts where two people have modified the same feature in different branches? And what this means is when you pull those changes together, you've got to figure out how, what wins, what was the correct change from these two changes that happened at the same time. And one of the goals that's really difficult to do in a command line, right? Like you can't visualize that change easily. It's not like text where you can be like, well, Jane's modified this line to be X and Bob's modified it to be Y. So part of the idea behind the GUI tool is to give you a visual way of solving those types of problems. So that'll be coming. I don't have a date for that, unfortunately.
Okay, I think it's great news that we should be expecting that. So that's really great. So I understand that. Correct me if I'm wrong here. That Kart repositories are offline, right? And so the question is, how does the aspect of multi-user editing come in? How does that happen? Say, for example, people are in different locations, right? They're not using the same network on the same computer. How do they use Kart to execute this multi-editing scenario?
Yeah, no, you're absolutely correct. So, and this is the sort of the distributed part of the distributed version control, is that everyone has a copy. So, your Kart repository is a Git repository. And if you're able to host a Git repository somewhere on your system or online somewhere, you can start collaborating with Kart. So, at Coordinates, we'll be building our own support for Kart hosting. And we'll bring our expertise around GIS and how you work with spatial data. But there are some differences in how because there are differences in how you want to work with spatial data versus things that are mostly text and files. But Kart repositories are still just Git repositories, and there are lots of different ways of hosting Git repositories just with a simple Git remote, or there are other bits of software out there. And our intention is that everyone should be able to do this, cheaply and easily, in lots of different ways that work with them. So if you've got your hosting sorted, all you need to do is set up some basic authentication, and then you should be able to start pushing and pulling data around.
Oh, that's really awesome. Thank you so much for that. So you did talk about QGIS earlier, and I found a Kart plugin for QGIS, right? And could you tell us how that works? Because apart from someone using the command line tool, the Kart, right, they could easily use QGIS from my understanding. So people that would rather use this approach, how do they go about this? And also a very second question to that is there plan to support other GIS software apart from QGIS?
Yes, we do have a QGIS plugin, and that's really great. It lets you work with Kart repositories directly within QGIS. It's still a pretty early release, and we'll be putting a lot more work into QGIS soon, but it's still pretty great to be able to clone. That's to get a copy from your online source and create branches and commit changes directly within QGIS. The plugin also supports some other advanced features like the spatial filtering of Kart repositories. So yeah, QGIS is a great project, and we're very keen to support it going forward. Beyond QGIS, yes, we are definitely looking to add support for as much software as possible. So for example, we're looking at publishing an FME transformer, but there's a whole range of software out there that we're very keen to see support Kart, and to give you a really good user experience within the software itself. And basically make it bring you closer to the tools so that you can start to use Kart as part of your normal workflow. And again, that's part of, you mentioned before about the graphical user interface and desktop app option. Being able to do some of those tasks within QGIS also means that you don't need to learn too much about the nuts and bolts of how Kart works under the hood as a command line interface, because we'll work with the QGIS workflows that you're already familiar with, and with a few small additions. Okay,
cool. So Kart is an open source project, right? So meaning that other people can contribute to it. So and it's also in active development, because I did check GitHub, and the last commit was quite recent. So is there any way that people can jump on this and contribute? And what languages are used for building Kart, so that maybe people can have an idea of that?
Yeah, there's lots of ways to contribute. And it's pretty cool to see on GitHub the there's lots of forks and stars and evidence that people are getting some value out of it. I think the first way to contribute is to give it a try, go out and use it, and to let us know your experience. So it's really great to hear from people who are getting value out of it. I think some of the best stories are, we hear on Twitter where someone's, saved their bacon because their software crashed, but they're able to recover their changes easily out of their Kart repo. So that's always good. That's the sort of thing that we're trying to do. But it's also good to hear about things that didn't quite work out as well. So talking about it, showing other people, writing about it is another way to get involved. If you want to start getting involved in the actual code, there's lots of bugs and features we'd love to see. You can jump on the GitHub page and have a look at some of the issues, and I think we try and tag some issues that are like good starting points as well. But it's an open source project, so if there's some burning feature in your mind that you want to get done, you can absolutely come in and do it. Most of the code is Python, so there's Python working with various libraries under the hood. Python's a pretty accessible language and fairly well used in the industry. So hopefully the barrier to getting started is fairly low. But even things like writing documentation is one area that is really valuable to us, and tutorials and that sort of thing. We're lucky to have a Google Summer of Code contributor this year, Amal Thundil, who did some great work around improving the command line help and the documentation as well. So those little, we call them sort of quality of life improvements, where they make it easier to use and easier for other people to get started, and those can really accelerate the project.
Awesome, that's really good to hear. Well, I think we are going to add the link to the GitHub repository in the show notes as well.
Yes, and let us know about it on if you're using it. Let us know on Twitter at Kart for Data. So Kart for Data is our Twitter handle. So let us know there.
All right, awesome. what's the roadmap? What's expected for the future? I mean, you did mention that if people think that there's a feature they might want to add, they could put out on GitHub. So what? I bet you already have like a roadmap, things that you want to add. Is that something you might want to share with the listeners?
Yeah, we have some of the roadmap on the Kart project .org website. What we're working on right now is support for point cloud and terrestrial LiDAR data. So I mentioned before that Kart is primarily vector data at the moment. We're looking to extend that at the moment. So we know there's an awful lot of research and activity happening around LiDAR at the moment. And we see Kart as a pretty good container format for being able to push and pull those around as well. And we'll be moving to raster, so aerial and satellite imagery and gridded data as well. Soon as well. So the idea is you can have all your vector, raster, and point cloud data all together in one place, and you can push and pull those changes around too. Beyond that, we're looking at how we support files and documents better. I'd like to be able to include your processing scripts along with the data, the source data, so you can do full reproducible pipelines for your changes. Another thing that is sort of important to the GIS world in a way that isn't quite so important for sort of the code world are things like formal metadata, so ISO metadata standards and licensing of your data as well. So we have some of that stuff built in already, but we want to improve how it's handled so that you can much more easily manage your metadata and your licensing information around your data as well. So, you get a lot of surety around the quality and use of your data, both internally and externally. Awesome.
Great. Thank you so much. So as a quick summary, Kart is I think it's an amazing software. It's an amazing project that's going on there. I'm sure it's going to gain the momentum that it should with time. And, like I mentioned before we started, the poll I did on Twitter, I believe that after this episode, a lot of people are going to hear about it and hopefully start using it. And with time, we're going to see that increase in the adoption of Kart for, version control of geospatial data.
Yeah, certainly will. I'm really thankful for this opportunity to share Kart as well. And I too am excited. I think we've got a really good project here that can help people work better with their data, reduce, how much time they have to spend doing data management tasks, and give them more opportunities and new ways to build with the data they have.
Yeah, absolutely. And I think I like the fact that it supports different already existing GIS data formats and the possibility of also connecting to a PostGIS database. I think that's also really brilliant. So say someone wants to maybe get in touch with you or in touch with the team, or just wants to know more about the project. How can they do that?
Let's see. Via Twitter. I'm trying to think what works for generally. So Twitter, if you're on Twitter, is easy. GitHub if you're on GitHub, or email at hamish.campbell@coordinates.com, I guess.
Okay, cool. Thank you. I'll be sure to add that to the show notes. Thank you once again, Hamish, for being here and talking about Kart. It was a pleasure. I hope people get to use and explore Kart and start integrating it into their GIS workflow.
Oh no, it's just absolutely. Thank you very much, and thank you for having me on your podcast, and have a great day.